So what the squeeze theorem tells us is that if you have a function that's always less than or equal to a function g, but it's always greater than or equal to a function h, there's an interesting little characteristic about it that happens to work out. And it is this. So what happens, you have a function h less than a function f less than a function g. That has to be true. What the squeeze theorem does is if you take the limit of the first function and you want to do the limit of the one in the middle, here's what happens. Sometimes you'll look up and this limit and this limit will be exactly the same. For instance, let's say this limit happens to be L. And let's say that this limit is the same thing. Well, where the squeeze theorem gets its name is that this function in the middle is squeezed in between these two. For instance, graphically, here's a graph of G, here's a graph of H. You see the function that's there in black? Do you see how it's kind of squeezed in between both of them? See that? Well, what the theorem tells you is that if the limit at x approaches c, if you do it for h and g and you get the same number, think about it. If this value is greater than L but less than L, it has to be equal to it. It's like if I tell Anna, you have more than $10, you either have the amount of money in your pocket is greater than or equal to $10. But the money in your pocket is less than or equal to $10. It's got to be $10. So by the squeeze theorem, if that happens, that has to be L. Okay. Now, what would a homework problem look like then? Well, for right now, the homework problems that y'all have had will look something like this. Now, here's one that's like number 87. They're going to tell you that 9 minus x squared is less than f of x, which is less than 9 plus x squared. And they're going to ask you to do the limit as x approaches 0 of your function. So here's the theory behind the squeeze theorem then. I check the first limit of the first function. You check the limit of the middle function. And then you check the limit of the third function. Easy enough. So what's this first limit going to be? 9. Just stick 0 in, right? Now I have no clue what this one is yet, do I? What's the limit of this? It's 9. So this has to be 9, right? That's the squeeze theorem. It's not it, and it's basic form. It's not that hard. Now it can get a whole lot more difficult than this, but for y'all just being introduced to it, it's really not that hard. Questions about that? All right, they also on the homework want you to look at this graphically. Now you may need to turn to the next page so you'll have some more room to write. You got that whole blank page there. So turn to that page there. And then when you get to 89 through 93 odd, they want you to do this with a calculator. And what they're going to tell you is to look at absolute value of x and look at negative absolute value of x. And for instance, on number 92, they want you to do the limit as x approaches 0 of absolute value of x times cosine of x. Now, you would think you could just plug 0 in and get the answer. But because this has some weird characteristics about it, it's got an absolute value and a trig function, you might want to check it graphically just to be sure. So what we're going to do in our calculators here in a minute is we're going to put this in F1, we're going to put this in F2, and we're going to put this in F3. Why? We're going to try to show graphically that this is true. That this function is less than this, and that's less than this. That's what we're going to try to show graphically. If that's true, then we do the limits of the first function and the last function, and we'll know what the middle function is. So this is just to kind of get your feet wet on Squeeze Theorem. So let's go to our calculators then. Alright, so let's press the home key. And go over to number 2 and get a graphs and geometry page. 84 folks, just do y equals. Alright, now on the inspires, to get absolute value, you need to do control and do times. And it's in this math type template. So I did control times. Control times, and it actually looks like absolute value. So I'm going to do enter and then type X. Now remember, go down when you want to type more stuff. If you press enter, it goes away on the new operating system. To get it back, you do Control G. Alright, now I'm going to do negative control times absolute value of X. Go down. Looks like an X, right? Now control times, I'm going to do absolute value of X, arrow over, times cosine of X. And then I'm done. Now, my last function, would you agree that that function that's blinking, that's dark right there, does it appear to be greater than the negative absolute value and less than the absolute value? Yeah, it looks like it's always true. Now, we're not proving that, but it does appear to be so. But we haven't proved it, but it does appear that that graph is less than this, but bigger than this. Alright, so that's all they want you to do is to verify graphically that that's the case. Alright, now that we've done that, if we do the limit of this first one, which is a joke, and we do the limit of this last one, which is a joke, we know the limit in the middle, which is a harder function that you may not know if you can do direct substitution or not. So since I know that's 0 and I know this is 0, then I know the limit in the middle is 0. So by the squeeze theorem, we know that's true. Questions about that? All right, so we've got one more thing to look at, and then we'll finally be caught up after all of our interruptions last week. Okay, if you'll go over a page or so and find the Coyote Problem. It talks about position function. All right. So what happens is there's actually two position functions that we can have for this scenario. All right, now the scenario here is that the position function s of t, usually in calculus, position is given by x of t or s of t. So what is this the position of? Well, in this case, it's the height of an object that's fallen for so many seconds. All right? So the idea here is we have not thrown the object up, and we haven't thrown the object down. It has just been dropped. Okay? Its initial velocity is 0 is what I'm getting at. So we're just dropping it. We haven't thrown it upward. We haven't thrown it downward. We've just dropped the object. All right. If that's the case, this limit right here gives you velocity. Now, in this chapter, I will give you that formula when I put this on a test. Next chapter, I won't. But this chapter, I'll give that formula to you. What does this h sub 0 mean? Not the initial velocity, but almost. The initial height. If it was initial velocity, it would have been v sub 0. So let's read our Wile E. Coyote problem and see if we can figure out the velocity. So it says, Wile E. Coyote, once again trying to catch the Roadrunner, waits for the nastily speedy bird atop a 900-foot cliff. Okay, so let's stop right there. So what is our position function then? What's the position function? Well, it's 900, right? Because what's the 900? That's the initial height, all right? All right, with his Acme rocket pack strapped to his back, Wile E is poised to leap from the cliff, fire up his rocket pack, and finally partake of a juicy Roadrunner roast. Seconds later, the Roadrunner zips by and Wile E leaps from the cliff. Alas, as always, the rocket malfunctions and fails to fire, sending poor Wile E plummeting to the road below, disappearing into a cloud of dust. How long after Wile E. Coyote jumped did he hit the road, and how fast was he traveling at that moment? All right, so let's think for a second. When he hit the road, what is his position? It's 0. But what variable is 0? I don't see a h in my equation I wrote. S of t, right? So, S of t is 0. That's his position. So how am I going to figure out how much time it took for him to hit the ground? What am I going to do with this number? Substitute 0 where? S of t. Now what? Solve for t. How? Alright, I heard move 900 over by subtracting. Now what? Divide by negative 16. Somebody tell me what that is? It's positive something. 56.25. Now what do I do? Square it? Square root it. Technically plus or minus, but since, he didn't hit the ground before he jumped off the cliff, we know the negative one's not going to matter in this case. So t is approximately, we're going to do 3 decimal places. What is it? 7 point, did it come out exactly? Alright, so I can erase the approximately. So is that answer good enough? Nope. That just says t is 7.5. Is that hours? Is it years? Seconds. Got to put a unit. You just put 7.5. I don't know what it is. Now, I need to know how fast was he traveling, all right? So this is where that little limit comes in. All right, it said up there at the top, to get velocity at t equals a, velocity at time equals a, it was the limit of t approaches a, and what did it say it was? S of a minus S of t over a minus t. So I want to figure out how fast was that coyote going when he hit the ground. Now what's a in this instance? What is it? Sure you do. Okay, so what time do we want to look at? Well, at the starting time, it was 0 because he was just up on the top of the cliff, right? He wasn't moving it. 7.5 because he hit the ground 7.5 seconds later, right? So you are looking at, to get the velocity at 7.5 seconds, you're going to do the limit as t approaches 7.5, and we're going to do s of 7.5 minus s of t over 7.5 minus t. Okay, so that's the limit we're going to have to calculate. Because a is 7.5. So that's the only place I substitute that, because I'm doing a limit here in a minute. Okay. So if you plugged it into t right now, everything would cancel and you'd get 0 over 0. So we don't want to do that quite yet. All right. what is S of 7.5? Think for a second. You shouldn't have to plug anything in. What does that represent anyway? Position. So what was the position of the coyote at 7.5 seconds? The ground, which is 0, right? So this is 0. S of t is just the function that we had up there a minute ago. Which was negative 16 t squared plus, and what was his initial height? 900. Alright, so this is where we're at right here. So I want to get the velocity of the coyote when he hits the ground. How could I finish this limit now? You could do difference of two squares. What's another way? That's how you do it algebraically. You could graph it. You could do it numerically, do a table, right? It's going to depend on the technology you have, right? Or don't have. Well, let's do it algebraically and see if we can do it that way. Now, Keithia says this is difference of two squares. What is square root of 900? 30. So let's see what that gives us then. So it's 4t minus 30, 4t plus 30. But on the bottom, I've got 7.5 minus t. Nothing cancels. I could. Question is, what do I do? There's a little trick you can do. Think. Well, let's go to your suggestion. If you factored something out, what would you factor out, and of what term? You'd factor out a 2 out of what? All right. Good idea. I wouldn't factor 2 out, though. 4. Excellent. This is one way of doing it. We're going to factor a 4 out of this. Now, the reason we picked this one is because that one's negative down there. So if anything's going to cancel, it has to be the negative ones, right? Okay, so this is one approach. There is another way of doing this, so we'll do it Lakeithia's way and see where this, and then we'll see if we can figure out another way of doing it. So she said factor a 4 out of that term. Okay, 4 times what is 4t? T. And then 4 times what is 30? 7.5. However, this is not exactly the same as this one, is it? So what do I need to do to that bottom term to fix it? Factor out a negative 1. And that changes the signs of everything. And then this cancels. So it looks like we're going to get negative 240. And I believe this was it feet? Yeah, feet. So this was feet per second. Now there is a way you could do this without factoring. What could I multiply the denominator and the numerator by so I wouldn't have to factor it all? Does everybody have that written down? Okay. What could I multiply the denominator by so it will cancel with what's in the numerator? Not 4, but -4. Well, you can't just do that. But if you multiply the bottom of that, you got to multiply the top by that. This is actually the easiest way to do it. So I've got -4, I have this, I have this. -4 times -t is 14. -4 times 7.5 is -30, and then they'll just cancel like right there. That's actually the easiest way to do it. And you still get -240 feet per second. Now I realize y'all haven't had much experience with the physics yet, but why is this negative? Downward, right? It's falling down. Okay. Excellent. All right.